Praying mantis. The female strikes mid-copulation, her spiked forelegs grabbing the male's head before her mandibles begin their work. What happens next is one of nature's most disturbing displays. She systematically devours his head while he continues mating with her, his body operating on autopilot. This isn't random violence. The female mantis eats her mate because she needs a massive protein boost to produce viable eggs, and a convenient meal just presented itself. Studies show this happens in about 13 to 28% of mating encounters in the wild, though it's more common in laboratory settings where the male can't escape. Here's what's really happening. The male's head contains inhibitory neurons that normally control mating behavior. When she removes his head, those inhibitors disappear, and his body actually mates more vigorously and for longer periods. It's a grotesque evolutionary trade-off where his death directly increases his reproductive success. The nutrients from his body get converted into eggs that carry his genes, so in a twisted way, he's investing in his offspring. To put this in perspective, a single male can provide up to 60% of the female's daily nutritional needs. The consumption typically starts with the head and continues through the thorax, leaving only the wings and legs. Females who consume their mates have been documented producing larger egg masses with higher survival rates. The entire process can take anywhere from 30 minutes to several hours, depending on the female's hunger level. Redback Spider. The male performs an acrobatic somersault during mating, deliberately positioning his abdomen directly over the female's fangs. This isn't an accident or a clumsy mistake. He's actively offering himself as a meal, and about 65% of males get consumed during or immediately after copulation. The reason behind this suicidal behavior is purely strategic. Males who get eaten mate significantly longer than those who escape, sometimes copulating for over 20 minutes compared to just 11 minutes for survivors. Longer mating time means more sperm transferred, which means higher likelihood of fathering the female's offspring. The female redback is also significantly larger and possesses neurotoxic venom that immobilizes prey quickly, making escape nearly impossible once she decides to feed. What makes this even more calculated is that the male actually controls the timing. He can choose whether to perform the somersault or attempt to mate and flee. Those who sacrifice themselves have a much better chance of reproductive success because the female becomes less likely to mate again after consuming a male. Basically, he's trading his life for paternity certainty. The nutrients he provides also help her produce more eggs, which benefits his genetic legacy. The male's body contains essential proteins and lipids that directly contribute to egg development over the following weeks. Females who cannibalize their mates show improved reproductive output compared to those who don't get this nutritional supplement. The entire consumption process releases chemical signals that actually suppress the female's receptiveness to future mating attempts. Black Widow. Despite the infamous reputation, the female doesn't always devour her partner, with rates varying from 2 to 10% in some species depending on environmental conditions. When she does eat him, it's driven by nutritional state and opportunity rather than species-wide programming. A hungry female is far more likely to attack and consume a male than one who's well-fed, which suggests this behavior is flexible rather than obligatory. The female Black Widow is substantially larger than the male, sometimes up to 15 times his mass, and her venom is incredibly potent. She needs significant protein resources to produce egg sacs that can contain hundreds of spiderlings, and a male represents a readily available high-protein meal. Males have evolved several strategies to reduce their chances of being eaten, including approaching only well-fed females, plucking specific patterns on her web to signal their intentions, and mating quickly before escaping. The sexual size dimorphism plays a huge role here. The male is so much smaller that he's basically snack size from her perspective. In the wild, cannibalism rates are actually lower than in captivity because males have escape routes and can assess the female's hunger level before committing. The widow's behavior isn't about malice. It's about resource acquisition during a metabolically expensive time when she's preparing for reproduction. The male's body provides concentrated nutrition at exactly the moment when the female's metabolic demands skyrocket. Research shows that cannibalized males contribute measurable increases to egg sac size and spiderling survival rates. The timing of consumption, whether during or after mating, depends entirely on how aggressively the female responds to her hunger signals. Chinese mantis. Stretching up to 5 inches in length, this species is noticeably larger than the common praying mantis, and the females are even more likely to consume their mates. Sexual cannibalism occurs in up to 50% of mating encounters with Chinese mantises, making it one of the most dangerous reproductive acts in the insect world. The driving force is identical to other mantis species, but amplified by her larger size. She requires enormous amounts of protein to develop and lay her supermassive egg cases called oothecae, which can contain up to 400 eggs. Each ootheca demands substantial nutritional investment, and the male's body provides essential amino acids and nutrients that directly improve egg quality and quantity. The male approaches with extreme caution, often waiting for the female to be distracted by other prey before attempting to mate. What's particularly brutal is that larger females have a higher cannibalism rates because they have greater nutritional demands and are more capable of overpowering struggling males. The behavior is more frequently observed in laboratory settings where males can't employ natural avoidance strategies like approaching from behind or mating only with recently fed females. In the wild, males have evolved to time their approaches carefully, but even with these adaptations, the risk remains extraordinarily high. She's not eating him out of aggression, she's converting him into the raw materials needed for successful reproduction. The sheer size of her egg cases means she needs multiple large meals during the reproductive season. Males who get consumed provide enough nutrition to support the development of dozens of additional eggs. Studies tracking female Chinese mantises show that those who practice sexual cannibalism produce egg cases with significantly thicker protective foam. Fishing spider. Living near streams and ponds, these semi-aquatic hunters face a unique challenge. The male must approach the much larger female on the water's surface, where escape options are severely limited. He risks both drowning and being devoured, and the female frequently chooses the latter. The reason she consumes him ties directly to her upcoming reproductive needs and the protein-intensive process of producing egg sacs that she'll carry with her. So female fishing spiders are significantly larger than males, sometimes double or triple his size, making him an easy target once mating concludes. Many males have evolved a fascinating strategy. They capture prey, wrap it in silk, and present it as a nuptial gift to distract the female during copulation. This gift-giving behavior reduces cannibalism rates because she's focused on eating the offered prey instead of him. However, even with this precaution, many males still end up as meals. The aquatic environment makes this particularly treacherous because the male can't simply flee across vegetation like terrestrial spiders. He's navigating slippery surfaces with limited traction while trying to mate with a powerful predator. The female's decision to eat him depends largely on her nutritional status and whether the nuptial gift was substantial enough to satisfy her immediate hunger. When she does consume him, she's securing nutrients that will support both egg development and the energy needed to guard her egg sac until spiderlings emerge. The male's body provides a concentrated protein source that's especially valuable since she'll be carrying and protecting eggs rather than actively hunting. Females who cannibalize their mates can produce egg sacs up to 20% larger than those who don't. The consumption ensures she has enough energy reserves to remain vigilant against predators threatening her offspring. By the way, if you're both horrified and fascinated by these brutal mating strategies, I make videos like this regularly. I'd appreciate if you subscribed. Thanks. Orb-Weaver Spider. The sexual size dimorphism in certain Orb-Weaver species is absolutely extreme, with females weighing up to 1,000 times more than their tiny male counterparts. The male is essentially a miniature sperm delivery system, so small that he can walk across the female's web without triggering her predatory response initially. This size difference evolved as a male strategy to avoid detection, but it backfires spectacularly after mating when the female's predatory instincts activate. She consumes him because from her perspective, he's indistinguishable from any other small arthropod wandering into her web. The female requires substantial nutrition to produce large egg sacs, and while an individual male doesn't provide much protein due to his tiny size, he's still worth consuming. What makes this particularly interesting is that the male's small size was supposed to be protective, allowing him to mate without being identified as prey. However, once mating is complete and he's moving around her web, she treats him like any other captured insect. Some males attempt to mate with females during their molting period when the female is vulnerable and less likely to attack. But this is risky because she's also less receptive. The extreme size difference means she's not deliberately targeting her mate so much as responding to movement in her web with standard predatory behavior. He's just collateral damage in her continuous hunt for food, and the nutrients from his tiny body contribute marginally to her reproductive output. Mantis Species. Across the mantis family, its sexual cannibalism serves the same fundamental purpose but manifests differently depending on environmental pressures and species-specific behaviors. The underlying reason remains consistent. Females need protein for egg production, and males represent an immediately available high-quality food source. In some species, males have evolved elaborate approach strategies, including only mating with females who are actively feeding on other prey, which drastically reduces cannibalism rates. The female's decision to eat her mate is influenced by her nutritional state, with with starved females showing cannibalism rates approaching 90%, while well-fed females might only consume males 20% of the time. This flexibility demonstrates that sexual cannibalism isn't inevitable, but rather a conditional strategy based on cost-benefit analysis. The male's body provides not just protein, but also lipids and other nutrients essential for developing healthy eggs with strong protective casings. Research has shown that females who consume their mates produce larger egg cases with higher hatching success rates compared to those who don't. What's wild is that some male mantises have evolved to continue mating even after being partially consumed, ensuring sperm transfer completes before death. The female isn't being unnecessarily violent. She's responding to hunger cues during one of the most metabolically demanding periods of her life, and the male happens to be conveniently positioned to meet that need. Certain octopuses. In several octopus species, the female sometimes attacks and consumes the male after he's transferred his sperm packet using his specialized hectocotylus arm. The motivation here differs slightly from insects and spiders because octopuses are semelparous, meaning both sexes typically die after their first and only reproductive event anyway. The female eats the male primarily because she's entering an extended brooding period where she'll guard her eggs for months without eating anything else. She needs every possible calorie to survive long enough for her eggs to hatch, and the male represents a substantial protein source. Males have evolved a cautious approach, sometimes detaching the specialized arm and retreating quickly to avoid becoming a meal, though this often proves futile. The female's aggression increases dramatically after mating as her body shifts entirely into maternal mode and she becomes highly territorial around her egg-laying site. Unlike the other animals we've discussed, octopuses are intelligent creatures with complex nervous systems, yet they still engage in sexual cannibalism driven by pure nutritional necessity. The male's body provides fats and proteins that sustain her through weeks or months of starvation while she aerates and protects her eggs, never leaving them even to hunt. It's a brutal but efficient system where his death directly supports the survival of their shared offspring, and honestly, given that he's going to die shortly after mating anyway due to genetic programming, becoming nutrition for the eggs carrying his genes is probably the most useful thing his body can do. Jumping spider. In certain jumping spider species, particularly those in the genus Phidippus, females occasionally consume their mates immediately following sperm transfer. The female eats him because she's preparing to invest enormous energy into producing and guarding her eggs, and his body provides a concentrated protein package exactly when she needs it most. Unlike web-building spiders that can passively capture prey, jumping spiders are active hunters who expend significant calories stalking and pouncing on prey. This hunting style means they need higher baseline nutrition, and the metabolic costs of egg production push those requirements even higher. Males attempt elaborate courtship displays with colorful body parts and intricate dances that can last up to an hour. It's true partially to assess whether the female is receptive and well-fed enough to spare him. However, even after successful courtship, hungry females will turn on their mates once copulation ends. The male's body contains lipids and proteins that directly enhance egg viability, with studies showing improved hatching rates among females who practice sexual cannibalism. The timing matters significantly, as females who've recently fed are far less likely to attack their mates than those who haven't eaten in several days. His consumption provides enough nutrition to sustain her through the early stages of egg development when she's most vulnerable. The nutrients also support the production of protective silk for her egg sac, which she'll guard aggressively until spiderlings emerge. Females who eat their mates show increased defensive behaviors around their eggs, possibly because the nutritional boost allows them to invest more energy in protection rather than foraging. Stick insect. In several stick insect species, females have been documented consuming males during or after mating, though this behavior is less common than in mantises or spiders. The female devours her mate because producing eggs in these insects requires massive amounts of protein and calcium, particularly since many stick insect species lay dozens of hard-shelled eggs over their lifetime. Males are generally smaller and less robust than females, making them manageable prey when the female's nutritional needs spike during reproductive periods. The cannibalism appears opportunistic rather than systematic, occurring more frequently when females are kept in captivity with limited food sources or when wild populations face seasonal resource scarcity. When it does happen, the male's entire body gets consumed over several hours, providing a substantial meal that can support the production of multiple eggs. Research on captive populations shows that females who consume their mates produce eggs with thicker shells and higher calcium content. The hard protective coating on stick insect eggs requires significant mineral investment, and the male's exoskeleton provides exactly those resources. Unlike mantises, where the male sometimes continues mating after decapitation, stick insect males typically die quickly once consumption begins. The female's powerful mandibles make short work of the male's relatively soft body compared to their tougher plant-based diet. Females who practice sexual cannibalism in this species also show accelerated egg-laying rates in the weeks following consumption. The nutritional windfall allows them to front-load reproduction, getting more eggs into the environment before potential predators or environmental hazards reduce their own survival chances. If learning about nature's most extreme mating strategies sparked your curiosity, consider subscribing so you don't miss future wildlife content. Thanks for watching.